Welcome to our channel Euclid Mathematics. So today I'm here with one of the topic from group theory, which is a relation and basic algebraic structure. So let's learn this topic with some of the examples from NET exam. Example from NET exam which asks for 3 marks and June 2018. Okay. So let's start our example. So example which depend on a permutation group. So we have to find out the element of order in permutation group. So here element it is given, okay, and we have to find out their orders. Okay, so in group theory to find the order for any element, so we have to use some of the results here. Okay, so let's read the question. Let S7 denote the group of permutation of the set. Okay, so S7 is having set here which contain element 1, 2, 3 up to 7. Okay, then we have to find out which one of the option is true. Okay, we have to find out correct option between these 4 options. Okay, so our first option, it says that there are no element of order 6. That means we have to find out the element whose order is 6 in S7. Okay, so we have to find out whether the 6 order element which exists in this set or not. Okay, so now next here there are no element of order 7 in S7. Okay, so again we have to find out 7th order element exists or not. Similarly, it is here for 8 order element, and last one is here for the element of order 10 which is present in our group or not. Okay, so for finding order of any element in ESN like a permutation group, we have to use one result, that if we wanted to find out the group which contain element in our set, okay, so we have to take the LCM of that different elements, okay, which contain in our set. Okay, so for example, if I consider sigma as a element from our group, okay, so if I consider sigma as an element, so sigma belongs to SN. So let's move for the solution. Okay, sigma here belongs to SN, and sigma which is a multiple of a C1 to CK. Okay, then C1 to CK which is from our group. Okay, and order of sigma means that LCM, okay, least common multiple between this C1 to CK. Okay, so length of C1 to CK. Okay, length means that element which contain in that cycle. Okay, now for partition of a group, okay, so we can use partition of a group for finding order of element. So partition of group means we have to partition the element in our set. Okay, so we have ES7 as a permutation group. So I will tell you how to find the partition of ES7. So ES7 contain 7 number of element. Okay, ES7 contains 7 number of element. Now find out the partition. Partition means we have to divide that 7 the way that we can get the sum 7. Okay, so 7 can be written as 7 plus 0, that means only 7. Okay, so next partition it goes to 6 plus 1, that is also 7. There is no any other element. When we add to 6 we get the 7. Okay, it is only 1. Now after of that it is a 5, so we can write 5 plus 2 as a 7. Okay, and after of it we can write 5 plus 1 plus 1. Okay, 5 plus 1 plus 1. So there is no any other element. Now let's move for the 4. So 4. So 4 plus 3, we know that the 7. Again go for the next 4 plus 2 plus 1. This is also 7. And after we can write 4 plus 1 plus 1 plus 1. Okay. So these are the partition for 7s. So go for the next further 3 plus 4. We cannot write 3 plus 4 because already we done it here. 4 plus 3 means 3 plus 4. Okay, now 4 plus, again now go for the 3 plus 4, option gone. Now 3 plus 3, 6, and here 1. Okay, so we can write 7 as 3 plus 3 plus 1. Okay, now next one 3 plus 2 plus 2. Okay, 3 plus 2 plus 2, it goes to 7. Okay, again 3 plus 2 plus 1 plus 1. Okay, 3 to 5 and it to 7. So all these are the partition of a 7. Okay, so we can find more partition here, but we have to find out the partition as per our question. Because of that we have to check the some certain elements from our question whether their order exists or not. Okay, so here I got it here, the element of all order it is here. Okay, so we have to find out the LCM of these elements. Okay, so we need some certain elements for our group, okay, which exists their order or not. Okay, so here LCM of a 7, it remains 7. LCM of a 6 and 1, it remains 6. So we have to find out the least common multiple for these two elements. Okay, LCM of a 5 and 2, it goes to 10. Okay, so LCM of 5 1 1, again 5. LCM of a 4 3, we have to find out the LCM of 4 3 which is a 12. Again 4 2 1, so we have to find out the LCM similarly for all other elements. Okay, now let's move as per our question. So in our question we want the element of order 6, 7, 8 and 10. Okay, so that means we have to find out the combination of elements which LCM is a 6, 7, 8 and 10. Okay, now let's move for the LCM of our elements. So as per our question, I selected some certain elements. Okay, their LCM is given here. Okay, I solved here their LCM as per our questions because we need this one in our options. Okay, so here first I selected 7. Okay, LCM of 7, it remains 7. That means in our group, permutation group, we have the element which order is 7. Okay, now let's go for the next 1 plus 6. That means element of order 1 plus 6. Okay, so take the element, their LCM 1 and 6 is the 6. Again 2 and 5, their LCM is a 10. 3 and 4, their LCM is a 12. 4 to 1, LCM is 4 to 1, it is a 4. Again 5, LCM of 5, 1, 1, it is remaining 5. And 2, 3, 1, 1. Okay, their LCM is a 6. Okay, so I got the element here 7, element of order 7, 6, 10, 12, 4, 5 and 6. Okay, these all are the order of our elements. Okay, so now we have to check whether which one of the option is correct. Okay, so in our option it is given there are no element of order 6 in S7, but we found the element whose order is a 6. That means element 1 and 6. Okay, their LCM is 6. That means whose order is a 6. Okay, so option first, which is wrong. Now their next option, it says that there are no element of order 7, but 7 is the only element whose order LCM is 7. So first option, our first partition of a 7, it gives LCM 7. So option B is wrong. Now option C, it says that there are no element of order 8. Okay, so exactly we didn't found any element whose order 8 in our S7. So this option is correct. Now let's check for the fourth option. Okay, there are no element of order 10 in S7. Okay, so but we found the element whose LCM of a 2, 5 is a 10. Okay, that means we have the element whose order is a 10. Okay, so within this four option A, B, C, D. Okay, so we got the only C option is correct and remaining A, B and D, which is a wrong option. Okay, so I hope so you all have understood my today's lecture, which is on permutation group and from the topic relation and basic algebraic structure. So everywhere similar type of the question repeated in set, net, gate and multiple type of competitive exam. So I hope so you all have understood. So thank you for my lecture everyone.